Now in section 4.8 and in some of the other examples that we're going to use for quadratics, we're going to look at the business application of a company that sells product. They need to price their product and then figure out their revenue and their cost and their profit. So let's just make sure we know the business side of what's going on here. All right, so there is a price. So let's say we sell, well, in the example we're going to look at, it's going to be small grills, but it could be any product. You know, let's say we sell cell phone cases. There's not a single price. There's going to be a price function. And the price function is, you know, probably going to be something x squared plus something x plus, you know, it's going to be a quadratic because the price of a product starts low and then you can increase the price, but then you'll maximize that would be the best price, and then if your price gets higher and higher and higher, the number of products you sell becomes fewer and fewer and fewer. So there will be a price function. And then x is usually, almost always, the number of units sold. So the number of cell cases sold. So my price for my cell phone case is going to be based on how many I sell. All right, revenue. Revenue is how much money the company brings in. In other words, what they can deposit in their account, in their checking account. So that's their income. Revenue is income, and revenue is always going to be equal to the number of units sold times the price function. So how much a company brings in is going to be how many sold times the price that we should sell the product at that quantity. So given my example, my revenue would be X. Nope, let me go ahead and, I'm not even going to go through that example. We've got a lot of examples of it. So revenue is always number of units sold times the price. Now there's also a cost for business. And the cost is not a single number. There might be some fixed costs like rent or stationery or salary. But then there'll also be a cost based on the number of units sold. So that is going to be a cost function. That's also going to be a function that is based on number of units sold. So my revenue is based on the number of units sold and the price I'm selling it at. The cost function is going to be based on the cost of manufacturing that many units. And then the last business topic we're going to talk about is profit. Profit is how much money the company gets to keep. Do they actually make any money? How much money do they, should we say, clear after they pay their costs? And profit is always equal to how much you bring in minus how much you've had to pay. So if how much you bring in is more than your cost, your profit is going to be positive. If your revenue is exactly equal to your cost, your profit is going to be 0. That's called your break-even point. You haven't made any money, but you haven't lost any money. And if your revenue is less than your cost, your profit is going to be negative. A negative profit is called a loss. So that's what we're going to be dealing with in this application in section 4.8 and some others as well. All right, so this company makes a popular line of indoor grills, and they predict that if they buy X units per week, the price is, okay, so we have our price function. We named it P, the price, how much we want to, what we want to price these indoor grills in is going to be negative 0.27x plus 61. So the price is going to be based on the number of units I sell. So number 1 says, recall that revenue is price times the number of units sold. So what is my revenue? My revenue is going to be X, which is number of units sold, times price. Let me go ahead and mark this. This is number of units, and this is the price per unit. Number of units times the price per unit, that's how much revenue you're bringing in. So I'm going to distribute that X, my revenue function, based on X number of grills being sold is going to be negative 0.27 x squared, because x times x is x squared, plus 61x. That's my revenue function. That's how much money I'll bring in. Now number 2 says that the cost is negative 1.2x squared plus 14x plus 570. Okay, again, it's based on the number of units. So write an equation that describes profit from selling X number of grills. So the profit for selling X number of grills is going to be the revenue for selling X number of grills minus the cost for selling X number of grills. So I'm going to fill in my 2 equations here. Revenue was negative 0.27 x squared plus 61x. That's my revenue function. Minus. Now you have to put your cost function in parens. We want to subtract the entire cost function. If you don't put your parens in, you're going to get a sign error for some of your terms here. And we have our cost. It's right here. Cost is negative 0.12 x squared plus 14x plus 570. So this is my revenue minus my cost. And I'm going to want to combine like terms. I'm going to want to make this easier to understand. So let me go ahead and make this negative 0.27 x squared plus 61x. Negative times a negative is positive 0.12 x squared. Negative times a positive is negative 14x. And negative times a positive is negative 570. So let me go ahead and combine my like terms. Here's an x squared, and here's an x squared. Negative 0.27 and positive 0.12 is going to equal positive 0.15 x squared. Negative 0.27 and a positive 0.12. Those combined is going to give me my 0.15 x squared. And since the negative number is bigger than the positive number, opposite signs you subtract and keep the sign of the greater. And now here I have a positive 61x and a negative 14x. So I want to combine my x's. 61 minus 14 is a positive 47x. And then I don't want to forget this. There's nothing to combine it with, but I still don't want to forget it. Minus 570. All right, this is my profit. And if profit is positive, I've made money. If profit is 0, I've broken even. And if profit is negative, I've lost money. So question number 3 says, find the profit if you sell 10 grills per week. So the profit when x is 10 is going to be negative 0.15. Don't put in the x, put in the 10 squared. Plus 47, don't put in the x, put in the 10. Minus 570. So when you type this in your calculator, you get negative 115. If they sell 10 grills that week, they're going to lose $115. There's a loss of $115. Their profit is negative. That's a loss. All right, so we definitely need to sell more than 10 a week to make some money. Question number 4 says, find the profit for 100 and 200 grills. All right, so that's interesting. What's the profit when I sell 100? That's going to equal negative 0.15. Don't put x, put 100 squared. Plus 47 times 100 minus 570. And when you put all in that in your calculator, you get a profit of $2,630. So if you sell 100 grills that week, you're going to make $2,630. Now let's see what the profit is if I sell 250 grills. Don't put in x, put 250 plus 47 times 250 minus 570. So my profit, if I sell 250 grills, is $1,805. And this does happen in business. What's happening here is if I'm selling more grills, I mean, it's good that I might think it's good that I'm selling more grills. I've sold 2.5 more times grills, 150 more grills, but I'm making $800 less if I do that. Okay, so selling 150 more grills means $800 less profit. That's why it's important for a business to know the optimal selling price and the optimal number of units that they want to sell. All right, so we're going to use a calculator or a computer to, number 5, to graph this equation. So we're going to go on our calculator. We'll clear that out. We're going to go into the y function, and let's put in negative 0.15 x squared plus 47x minus 570. So in the y1 function, I have negative 0.15 x squared plus 47x minus 570. All right, on the X, my X scales, my X min, let's start at 0. The fewest number of grills to sell would be 0. And let's go up to 400 grills with ticks at every 100. That's my X graph settings. On the Ys, so this is the X min, the X max, and the X scale. For my Ys, because I kind of want to see where it crosses 0, we'll put in negative 200. We'll go up to $5,000 profit, and our Y scale is going to be 1,000. So what this is going to do is we're starting at 0 and going up to 400 by hundreds, 100, 200, 300, 400. That's what this says. And on our window, we're going to have negative 200, just so we see where that line is. And we're going to have 1,000, 2,000, 3,000, 4,000, 5,000. So how do I put this on my calculator? Right here under window, my X min is 0, my X max is 400, and my X scale is 100. My Y min is negative 200. My Y max is 5,000. And my Y scale is 1,000. So now when I graph my function, this is what I get. This is my revenue. So I can actually lose some money here, or if I sell more than this, whatever number this is right here, I can lose money. But this is my revenue. I'm going to actually change my X min to something where I can actually see the ticks here. Here we go. We'll change that X min to negative 20. So we can see the ticks along the axis there. Okay, so 1,000. What was our question here? Use it to estimate the number of grills they'd need to sell to make the largest possible profit. All right, so that's going to be right about there. So there's 100, 200. It's a little more than half. About 160 grills to make the maximum profit. If you were to drop down here, you'd see that it's a little bit more than half, between 100 and 200.